Fusion reactors just got smarter. Because fusion's real bottleneck is no longer just heat, it's control at machine speed. Right now, AI is moving inside the control loop of tokamaks, where milliseconds decide whether a plasma holds or collapses. So what happens when a reactor becomes too fast, too nonlinear, and too complex for human reflexes or hand-tuned rules? Fusion isn't blocked by fuel. It's blocked by control. Plasma hotter than the sun's core can go unstable in milliseconds, and no wall can touch it. A tokamak is trying to hold a tiny star inside a metal chamber, but the star cannot touch the chamber because reactor plasmas run above 100 million degrees Celsius. And ITER-class operation is on the order of 150 million. So, engineers use magnetic fields instead of physical contact, shaping charged particles into a suspended ring. The problem is that this ring can kink, wobble, leak heat at the edge, or suddenly disrupt. And that raises the real question. Can a machine learn to steer plasma faster than instability can grow? The answer began in Switzerland, where an AI system was allowed to command a real tokamak in real time. In 2022, DeepMind and the Swiss Plasma Center reported in Nature that a reinforcement learning controller operated the TCV tokamak in Lausanne. It did not move one knob. It directly commanded 19 magnetic coils. First, the controller was trained in simulation, where it tried actions, measured whether the plasma shape improved, and learned which coil currents pushed the plasma toward a target configuration. Then, that policy was transferred to the real machine, where diagnostics fed back the plasma state as the controller updated coil commands in real time. It produced elongated plasmas and even droplet-like shapes that conventional control struggles to handle. This is separate from NIF's 2022 laser ignition result, 3.15 megajoules from 2.05 megajoules delivered, because that is inertial confinement, not tokamak control. In magnetic fusion, AI is also being tested to predict disruptions earlier, with PPPL reporting warnings up to 300 milliseconds ahead. Precious time for mitigation. That is what happens when fusion outruns human control. You hand parts of the reflexes to software. AI can read dense diagnostic streams, forecast instability precursors, and tune actuators on the timescale the plasma actually lives on. Milliseconds, not meetings. Over the next 10 to 20 years, smarter control stacks could make reactors more repeatable, more available, and more economically credible. But they will not erase materials limits, tritium handling, heat exhaust, or cost. They make fusion operable, not effortless. Fusion was never waiting for more fuel. It was waiting for faster intelligence at the edge of instability. That may be the control layer